Welcome to VK Lectures. In this lecture, we are discussing the question number 31 and 32 from Physics question paper for Kset 2018.
The electric field created by a charged sphere of radius r having a charge density or charge distribution rho equal to rho naught r is given by. So you have to find out the electric field created by the charged sphere of radius r whose charge density or charge distribution is given by rho equal to rho naught r at two places. That means E less, which is less than capital R, and for E larger, which is greater than capital R. Okay, that means you have a sphere of radius capital R and you have to find out electric field inside and outside the sphere, where here you have R less than capital R, and at this point outside the sphere you have R greater than capital R. So you have to find out inside and outside the sphere. Now here this is a formula for finding the electric field by Gauss law. E dot ds is equal to q by epsilon naught, which is nothing but in terms of rho it is integral rho dv by epsilon naught. Now on the left hand side you can write E into ds, that is nothing but E. First let us find out E less. So E less into 4 pi r squared is equal to 1 by epsilon naught times integral rho dv. What is rho? Rho is nothing but rho naught times r into dv. dv is nothing but in spherical polar coordinates, dv is equal to r square dr sin theta d theta d phi. Okay, so r into r square dr sin theta d theta d phi. Now when you integrate r, you have to integrate from 0 to small r. When you are integrating theta, it is from 0 to pi, and integration of phi from 0 to 2 pi. Okay, so E less into 4 pi into small r squared is equal to 1 by epsilon times rho naught r into r square r cube dr, that is nothing but r power 4 divided by 4 into sin theta d theta integral from 0 to pi, that is nothing but 2 into 2 pi integral, that means 4 pi. So E less, what you want? E less, this 4 pi and 4 pi gets cancelled. So what it is remaining? R square and r power 4, r square will remain on the right side. So E less is equal to rho naught by epsilon naught into r squared divided by 4. So your E less is this much. Now what is E greater? E greater would be on the right hand side you have to integrate from 0 to capital R. You change this small r to capital R, you get E greater. So that what you get here, so E greater into 4 pi small r squared equal to 1 by epsilon naught times rho naught into capital R power 4 divided by 4. Okay, and 4 pi here, 4 pi and 4 pi will get cancelled. E less is equal to, bring this r square to this denominator, is equal to rho naught by epsilon naught r power capital R power 4 divided by 4r squared. So your option A is correct option. Now I will tell you another method, or another method means using dimensional analysis how to solve this problem. So the same problem we can also use dimensional analysis. Dimensional analysis. Okay. Now what we want electric field. So electric field into 4 pi r squared is equal to rho v by epsilon naught. So electric field will have 1 divided by 4 pi r square into rho v divided by epsilon naught. So this should have, so 4 pi is a constant, rho we can write it as rho, and v is proportional to r power 3, that is r cube, and r square will come in the denominator with epsilon naught. So finally you have rho r divided by epsilon naught. Okay, this should be the formula. Or what is rho here? Rho is nothing but rho naught r. So we can write electric field should be having a dimension equivalent to rho naught into r square divided by epsilon naught. Okay, rho naught r square divided by epsilon naught. Now look at this first option, rho naught r square by 4 epsilon naught. So this can be a correct option. We are not sure about the constants. Again, rho naught r power 4 divided by 4 epsilon naught r square. So r power 4 and r square. In the numerator you will have r squared, which is also can be a correct option. Now look at the second and third option, B and C. Rho naught r by 3 epsilon naught, not correct. Rho naught r cube by 3 epsilon naught r square, again it is not having the same dimension. Rho naught by epsilon naught, again it is not correct. Rho naught r cube by 2 epsilon naught r square, it is having rho naught r, so it is also not correct. Now look at the last option, rho naught r by 4 epsilon naught, this is not correct anyway. Now rho naught r power 4 by 4 epsilon naught r square, this can be correct. Okay, but in the last option, since this cannot be correct, the only one option which is having both same dimension as electric field as we discussed here, option A is correct. Now when to check dimensional analysis, when to go with dimensional analysis? The moment you get the question, you please go through the options. If you are getting different dimensions for the same quantity, if you are getting different dimensions in different dimensions for same quantity, then go for dimensional analysis. Just by looking at the options you can understand whether it is having the same dimension or not. Okay, so here for the 31st question you have option A. A thin conducting wire is bent into the form of a circular loop of radius r and is placed in a time dependent magnetic field B of t. Then induced EMF in the loop. Then induced EMF according to Faraday's law is equal to E is equal to minus d phi b by dt, total time derivative of phi b, which is nothing but flux. Now phi b is given by BA cos theta. Now where theta is the angle between B magnetic field and the area vector A. Now we need the induced EMF, that is equal to d by dt of, let me write minus d by dt of B. What is B? B is nothing but B naught e to the power minus alpha t into A is nothing but pi r square. Now you can take pi r square and B naught outside. Pi r square B naught, the minus sign, into derivative of e to the power minus alpha t, minus alpha into e to the power minus alpha t. So that's equal to minus minus get cancelled. Alpha pi r squared b naught into e to the power minus alpha t. This is the induced EMF. So what is the answer? Pi r square alpha b naught e to the power minus. So your answer is A. So please remember the induced EMF from Faraday's law.
Here are two questions for practice, 33 and 34. You can please try to get the answer. We will be trying to solve this question in the next video.